We are looking at question 3 from your free response 4 assignment. And this question, which I find very interesting, is talking about this idea of marginal social cost, marginal social benefit, marginal private cost, and marginal private benefit. And also this idea of positive and negative externalities. So we have a situation where people are firing off fireworks. And we're assuming that the market for fireworks is perfectly competitive. And we want to draw and correctly label a graph for the market for fireworks. And show the market equilibrium price and quantity. Okay, so that's very easy, right? It's just a simple, let's jump over here. It's just a simple supply and demand. Actually, you wouldn't even have to have your second curve right here in here at all at the beginning. Okay, so you're going to draw that and you're going to show now remember, this is the market, not the firm. So in the market, in a perfectly competitive market, the demand curve is downward sloping and the supply curve is upward sloping, and you want to show price and quantity at a market equilibrium where the supply is equal to demand. So right here. So that's all you simply need to do for the first part of this question. Part A, right? Now in B, we're going to assume that there's a negative externality. It doesn't actually say that, but that's what this is, because the fireworks are disturbing the neighbors. So the fireworks are incurring a social cost on the neighbors. So we want to draw the marginal social cost curve, and we want to show the marginal social benefit, and we want to show deadweight loss shaded in. Okay, so that's where we get this second part, this curve. Your higher or to the left, your supply curve, that is your marginal social cost, which is at a cost higher than the private social cost. We can actually say, let me just jump down here. We can actually, let me just clone this so we can see. So the actual supply in the market is the marginal private cost, but because we have this negative, and I should say that, I should write that in here. So let me just do that. Negative externality. If I can spell it, externality. Let me just change that to something a little bit. Then we're going to have a social cost higher than the private cost at the same quantity. So we draw a second upward sloping supply curve that is up and to the left of the original. Okay, now then we can say that now we know that if we were actually going to, and let me actually clone one more thing. Let me clone something else here, just so we can show this. Let me clone this, if it'll clone, and clone this, so we can show. Now we can show that now with this negative externality, the socially optimum price in the quantity would be a higher price and lower quantity right here. This would be a socially optimum. This would drive down the quantity of fireworks, so drive down the noisy disturbance, and the works would have to be purchased at a higher price. Now, when we compare this point right here with where we are here, and what that cost would actually, and what that actual social cost is right here, which is from here to here, is the actual social cost. This defines our deadweight loss that we're experiencing if we stay right here. Okay, if we stay at the market equilibrium, we're going to experience a dead weight loss defined by moving up to the higher marginal social cost curve and then over to that lower quantity and higher price. Okay, so that's your dead weight loss with the negative externality. Okay, now why I find this problem fascinating is because it shows us that the exact same product and the exact same actions can also be a positive externality, because in this case the neighbors are enjoying the show. They don't mind the noise at all, so there's no negative here. There's no negative externality, but however, there's a positive. They enjoy it. It brings, it's fun to watch. It's exciting. So now we want to look at what this would look like. So this is a little bit confusing, so I'm drawing a second graph to show you better what this would actually look like. So the thing to keep in mind here is if there is a positive externality, that is going to mean that the marginal social benefit is actually higher than the marginal private benefit, which is the opposite or different from the negative externality. So in the negative externality, we have a higher cost curve. The marginal social cost is higher than the marginal private cost. And that's when fireworks are undesirable and it's a negative externality. Now, with the positive, let's shift down here, your marginal private cost equals your marginal social. So I could add right here, I could also say that equals your marginal social cost. So they're one and the same. When there is a positive externality, let me actually clone this real quick so we're all clear on this, right? Clone this and change this to positive, right? POSI, right? So when there's a positive, which we have right here, our supply equals marginal private cost equals marginal social cost. However, we're going to have a higher marginal social benefit. So this case right here is no longer true. The market demand is the marginal private benefit. That's the private benefit. But when we have a positive externality, when fireworks are desirable and we get something extra out of them because the neighbors are enjoying them, then we have a marginal social benefit that is outwardly, that is higher and to the right of the marginal private benefit. So we draw a second marginal social benefit curve out here, which defines the benefit that is gained by the neighbors enjoying the show. So we can say that the actual point, so the equation is at, whoops, sorry about that. The equation is asking, let's go back. Is the market equilibrium quantity of fireworks greater than, less than, or equal to the socially optimum quantity? Well, it's going to be less, right? So we come back over here, the market quantity is right here. But when we shift to a higher marginal social benefit curve, our actual socially optimum quantity is actually, whoops, sorry. The actual socially optimum quantity, I can't get the right guy here. Let me grab him. Not that. Okay, let me just do this. Okay. is here, right? Because this is now our new point. So the quantity at the socially optimum quantity is actually greater. So we can, if we wanted, we could clone this guy right here and put him in to just show that, right? At a higher price also, too, right? So we can say the socially optimum point are here, right? Now, so the answer would be that the market equilibrium quantity right here, I'm not sure I'm going to be able to get him anymore, right? No, I'm not. You know what? Let me just anyway, just here, right? This is actually less than the optimum. So the market equilibrium is less than the optimum. And I'll put him back right there. So that's what they're asking. The market is less than the optimum. And you can explain that by saying that, well, because of the positive externality, the marginal social benefit is greater than the marginal private benefit, so that it's a curve that's shifted out into the right, and that's going to make both the price and the quantity higher. And you can also say that is because the whole concept here is that there's benefit here not to just the purchasers or the consumers of the fireworks. This curve right here, I wish I could get him out of there, but I can't wait. This curve right here is the benefit of the actual buyers. This benefit right here adds on the benefit of the neighbors who didn't buy them but are still enjoying them. Okay? So that's how that's good. That's the concept behind all that. Okay. The last part of this is, okay, if there is a positive externality and we have a marginal social benefit greater than marginal private benefit, if the government bans fireworks, will the deadweight loss increase, decrease, or remain unchanged? Well, it's easy to see if we just think about the quantity. Banning means we go down to a zero, right? The quantity of a zero. But anything less than quantity at market equilibrium is going to, anything less than that, if there wasn't an outright ban, but just say the government said, you're only allowed to buy one package per year or something, so that would lower the quantity. Anything that would lower the quantity at all would actually create a bigger deadweight loss. So if I put this guy in here right here, that would be what would happen roughly if the quantity was lowered, down to here. And obviously if it was lowered down to here, this guy's going to get, right, it's going to get huge. It's going to be something like, even larger than that. It's going to get like something like that. Can't even draw it in there, right? Something like that, right? So you're going to have a huge deadweight loss if you didn't produce any fireworks at all based on, what we know about the demand and the supply in the market. Let me see if I can tip that guy, make it a little, there we go. So it would be something about, playing around, right, you see it, right? It would be something about here, actually, it would be this whole area here, right? So it would be huge. So you can easily see that if the government banned the fireworks, then the deadweight loss would certainly increase. So that pretty much takes care of, and I find that a very very insightful, very informative problem that hopefully helps you really get a deeper understanding of what happens in a perfectly competitive market when there is a positive or a negative externality. Okay? And that is it for free response 4.